Welcome to today's lesson. We are going to deal with prime numbers. The previous lesson, we've been looking at the divisibility tests. And when we are looking at the divisibility test, we looked at the divisibility test for numbers 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. Whereby we said 7, among the numbers between 1 and 11, 7 is the only number that its divisibility test is yet to be found. Prime numbers, we start by defining what a prime number is, and you're simply saying that a prime number is a positive whole number that has only two factors. So that positive prime number with only two factors. Which are these two factors we are talking about? The two factors are 1 and itself. So when we meet a number that has only two factors, that is 1 and itself, then we say the number is a prime factor. Apart from prime factors, we have those numbers that have more than two numbers that have more than two factors. We now refer to them as composite numbers. So we have composite numbers and prime factors. So composite numbers are made up of several prime numbers. So you'll discover that they don't have two prime factors, but they have more than two prime factors. So a prime factor has only two factors, that is 1 and itself, but a composite number has more than two factors. They could be 2, 3, 3, 4, and so on, so that you have more prime factors that are making up that composite number. It is important to note that 1 is not a prime factor. It is not a prime number. And at the same time, 1 is not a composite number. So 1 does not fall in a category of a prime number, and at the same time it is not a composite number. Why? Because 1 has only one factor, and you're talking about a prime number having two factors, a composite number having more than two factors. So meaning 1 having only one factor, then it means that it is not a prime number, at the same time it is not a composite number. So when we are talking about prime numbers, maybe between 1 and 10, the prime numbers we have, just to mention, we have 2, 3, 5, 7, as the prime numbers that are there between 1 and 10. We discover that 4 is not a prime number, it is a composite number. So these are prime numbers. Numbers between 1 and 10 are 2, 3, 5, and 7. So 4 is not a composite number. Is not a prime number, it is a composite number. 6 is a composite number. We have 8 and 9. Why are we saying that these are composite numbers? We are finding the factors that are making up 4. Factors making up 4, we have 1, 2, and 4 itself. The prime factor is 2, 2. So we find that how many factors do we have in total? 2 is repeated. We have 2 numbers. We have 3 factors. In 6, we have 1, we have 2, and 3. We have 1, 2, so the factors making up 4, we have 1, 2, and 4. Factors making up 6, we have 1, 2, 3, and 6. Factors making up 8, we have 1, 2, 4, and 8. Then factors making up 9, we have 1, 3, and 9. So what are we talking about? Here we have only one factor. Factor making up 2 is 1 and 2. Factor making up 3, we have 1 and 3. Factors making up 5, we have 1 and 5. Then factors making up 7 is 1 and 7. So prime factors, numbers that are having only 2 factors, that is 1 and itself. An example, 2 has only 1 and 2. 3 has 1 and 3, 5, 1 and 5, 7, 1 and 7. Then composite numbers, we are saying that they are made up of more than 2 factors. So the factors making up 4, we have 1, 2, and 4. Making up 6, we have 1, 2, 3, and 6. 8, we have 1, 2, 4, 8. 9, we have 1, 3, 8. So these are composite numbers, and these ones are prime numbers. So a question comes in, and this is what we are asked to do. State whether each of the following is a prime or a composite number. The first number we have is 14, and we need to find out how many factors does 14 have. And we find that the number of factors making up 14, we have 1, 2, 7, and 14 itself. So we find that this number has more than 2 factors, and since it has more than 2 factors, then it is a composite number. The second number we have is 23. So we find out the factors making up 23, and we get that 23 has the following factors. We have 1 and 23 itself. So since we have only 2 factors, then it means 23 is a prime number. The other number we have 70. 70 has 1, 2, 5, 7, 10, 11, We have 14, we have 35, and 70 itself. So we find that this one has very many factors. So since it has so many factors, then it is a composite number. Another example we have is 37. 37 has only 1 and 37. So since it has only 2 factors, then it is a prime number. Then we have so many other numbers that we can test with, but let us just work out the last 2 numbers we have. In this case, we have 51 and 49. So we need to find out, is 51 a composite number or a prime number? So the factors making up 51, we have 1, 3, 1, 3, 17, and 51. So meaning more than 2 factors, this is a composite number. 49, we have 1, 7, and 49. So more than 2 factors, meaning it is also a composite number. So when you discover that your number has more than 2 factors, then it is not a prime number, it is a composite number. So we are given a composite number in this question, and we need to find the prime numbers that are making up that composite number. An example is 42. We need to find out which prime numbers are making up 42. So if we have our 42 as the number, the first prime number we are coming across is 2. So 2 into 42, we have 21. The next prime number is 3. 3 into 21, 7. Then 7 is the last prime number we have. So we discover that the prime numbers that are making up 42 are 2 multiplied by 3 multiplied by 7. So these are the prime numbers that are making up 42. Another number we have we have 39. We are required to find out which prime numbers are making up 39. So we started by divisibility test, and from the divisibility test, we already know the divisibility test for 2, 3, 4, and so on. So 2 being the smallest prime number we have. If we confirm if this number is divisible by 2, we discover that our last digit is 9. So meaning the number is not divisible by 2. The next prime number we are having is 3. So we want to find out if this number is divisible by 3. Simply add 3 plus 9 is 12. And we get that 12 is a number that is divisible by 3. So meaning our first prime number that we meet in this case is 3. So 3 into 39 we have 1, 3. So 13 is the next prime number. 13 into 13 we have 1. So it means that 39, the prime numbers making up 39 will be 3 multiplied by 13. Maybe one last sum or problem to be solved. We have 28. So starting with 2 as the lowest prime number we have, because the number is divisible by 2 because our last number is 8. So the lowest prime number is 2. 2 into 28, we have 14. Another prime number is still 2. 2 into 14, that is 7. Then 7 into 7, 1. So the prime numbers making up 28, we have 2 times 2 times 7 as the prime numbers making up 28. So after tackling the prime numbers, we discover that there are times when you will have to write the same number repeatedly. When you are writing the same number, like where you are given a composite number and you discover that the composite number has repeated numbers, has repeated prime numbers. Like for instance, we've just seen 28 and we've found that 28 is 2 times 2 times 7. So the 2 is repeating. When we are having a repeated prime number being occurring, so we have a repeated prime number that is occurring. In this case, we refer to this as an index. So this can be written in index form. What do we mean by index form? When we are talking about index notation, we are simply referring to a number that is going to be written. We have a number that is a prime number that is occurring repeatedly, or a number, not necessarily prime number, but a number that is repeated. It is repeating itself in the... So we are saying this, when you are having repeated multiplication of the same factors, repeated multiplication of the same factors, then the number can be expressed in index form. So when you have repeated multiplication of the same factors, then we can express that number in index form. So what do we mean by this index form? We are writing our numbers in power notation, such that when we are writing this number, for example, if I'm having repeated factors, like my 2 is repeated, let's say 7 times or 5 times, let's use 5. So I'm having repeated multiplication of 2 5 times. 2 is repeated 5 times. So what do? I write this number in power notation such that 2 becomes my base. Then the power or the index that will be formed is just by how many times has the 2 been repeated. So this one has been repeated 5 times. So my power is 5. So in this case, 2 is my base and 5 is the power. Or if we don't use the power or the index, then we say that this is our exponent. So it is a power, an exponent, or an index. If there are several numbers, let's say we have 2 to power 5, we have 3 to power 2, then we have 2 powers. Index is when it is in singular, but when in plural, then we have indices. So we have index of 5, index of 2. The 2 are 2 powers. So the 2 powers in plural, we are talking about the indices. So that is what we are looking at in this discussion. So let us look at the indices and find out how do we write our numbers in index form. So we have the following and we need to convert into index. So we are given some multiplication and we need to convert to index. So we have 3 times 3 times 5 times 5. We convert it in power form. So converting it in power form, we have the first repeated factors. We have 3 and 3. It is being repeated twice. So my base is 3. Then the 3 has been repeated twice. So it is to power 2. Multiplied by the next number, our base is 5. 5 has been repeated 2 times, so it means the power is 2. So 3 times 3 times 5 times 5 in power form will be 3 squared times 5 squared. So we have 7 times 7 times 2 times 7 times 2. In this sum, we need to find out which numbers are being repeated. So we discover that we have 7, we have 7, and we have 7. So I can rearrange my statement and have the repeated numbers such that I have 7 times 7 times 7. So I've catered for that 7. The next numbers that are being repeated are 2, so we write 2 times 2, and we discover that we've covered all the numbers in that question. So we are having 7 being repeated 3 times, so it means this will be 7 to the power of 3, multiplied by 2 is being repeated twice, so I'll have 2 to the power of 2. So we get that number written in power form will be 7 to the power of 3 times 2 to the power of 2. So we have 13 times 7 times 13 times 7 times 7 times 7. We discover that the 13 is being repeated twice. So 13 being repeated twice, we have 13 to the power of 2, multiplied by 7 has been repeated 4 times, so we have 7 to the power of 4. So when you are converting a number to power form, we are converting it into an index form. We simply count how many times has the number been repeated. Then write that number as your base, and the power will be the number of times the number has been repeated. So count how many times the number has been repeated, write the number, the power is the number of times that number has been repeated. Next, we are supposed to expand we are supposed to expand these numbers, but as we expand, the issue is we are not supposed to evaluate. So we simply expand and leave the answer in the form, the expanded form. So we have 2 to power 4. 2 to power 4, it means that 2 has been repeated 4 times. So we multiply 2 4 times. Repeated multiplication of 2 4 times. So we have 2 times 2 times 2 times 2. So we've expanded, but we are not evaluating. So we are not simplifying our answer. We leave it in that form. The second question we have 9 to the power of 3. It means that our 9 is repeated 3 times. So we write 9 times 9 times 9. Another number we have is 3 to the power of 5 times 2 to the power of 3. So the first number we have is 3 to the power of 5. It means that my 3 has been repeated multiplication 5 times. So we have 3 times 3 times 3 times 3, 2, 3, 4 times 3. So 5 times. Then 2 is repeated 3 times. So I have 2 times 2 times 2. Next number we have is 11 to the power of 5 multiplied by 9 to the power of 2. So 11 is repeated 5 times. So we have repeated multiplication of 11 5 times, then repeated multiplication of 9 2 times. So that is how we expand when you've been given a number in power form. Evaluating numbers with power form. So what are we supposed to do? The question asks us to evaluate the following. The first one we have is 3 squared plus 4 squared. So we are having 3 squared plus 4 squared, and we've simply said the power simply means that there is repeated multiplication. So if I expand this, then it means we have 3 times 3 plus 4 times 4. Then we apply the BODMAS, where we'll deal first with multiplication before we go ahead, and then after that we will go ahead and add. So we have 3 times 3, which gives us 9. 4 times 4 gives us 16. So we have 9 plus 16, which gives us 25. Another example is we have 8 squared minus 2 times 3 squared. So 8 squared means the 8 has been repeated twice. So we have 8 multiplied by 8. Then minus 2 times 3 squared means we have 3 repeated multiplication of 3 twice. So that is 3 times 3. Then we go ahead and multiply first before we subtract the values we've obtained. 8 times 8 is 64 minus 2 times 3, that is 6. 6 times 3, we are having 2 times 3 is 6. 6 times 3, 18. So 264 minus 18. We borrow 1 from 6 to make it 14. 14 minus 8, that is 6. we were left with 5. 5 minus 1 is 4. So we get that 64 minus 18 gives us 46. Another sum we have is 9 minus 5 to the power of 4. So we have the brackets. We simplify what is in brackets first. 9 minus 5 is 4. So 4 to the power of 4 means that our 4 is repeated 4 times. So I have 4 times 4 times 4 times 4. 4 times 4 is 16. 16 times 4 gives us 64. 64 times 4, we are having 4 times 4, that is 16. Write 6, carry 1. 4 times 6, we have 24. 24 plus 1 is 25. So 16 times 4 gives us 256. So 4 to the power of 4 is simply 256. That is one of the options we can opt for in this question. Or alternatively, instead of working out whatever we have, the brackets means that. So the question is, which of these numbers has factors which are prime numbers? So we need to find out the factors that are making up the number and find out, are the factors prime or not? So we have 12. The factors making up 12. So 2 into 12, that is 6. 2 into 6, we have 3. Then 3 ones. So this means that 12 is given by 2 times 2 times 3. So 2 times 2 can simply be 4 times 3. So we find out that 2 is repeated here. This is 2 squared times 3. 2 squared is 4. So we discover that the factors of 12 is 4 times 3. And 4 is not a prime number. Our prime number here is only 3. So this 2 is being made up. Yes, 2 and 2 are prime numbers. But when I simplify 2 times 2, we are getting 4. So when this one is simplified, it's 4. So it means that the 4 that is making up 12 is not a prime number. So 12 is made up of factors that are, one of it is a prime number, but the other factor is not a prime number. Another number we have is 14. So we need to find out the factors making up 14. So 14, the first prime factor I have is 2. 2 into 14, that is 7. 7 into 7, 1. So we discover that 14 is given by 2 times 7. 2 is a prime number. 7 is also a prime number. So we have 14 is a number that is made up of the factors that are prime. So we get that the factors making up 14 is 2 and 7, and 2 and 7 are prime numbers. Another number we have to confirm, we have 18. 18, the factors making up 18, we have 2 into 18, that is 9. The next factor is 3. 3 into 9, we have 3, then 3, 1. So it means that 18 is 2 times 3 times 3, which gives us 3 is repeated. If I write 3 in power form, then I have 3 squared. 3 squared will give me 9. So 18 is simply 2 times 9. So in this case, 2 is a prime number, but 9 is not a prime number. So it means 18 is a number that is made up of one prime number and a composite number. Then another number, we have 20. To confirm if 20 is a composite, I mean a number that is made up of factors that are prime or not. So let us find out. 2 into 20, we have 10. 2 into 20, that is 5. Then 5, 1. So this makes up 2 times 2 times 5, which is 2 squared times 5, and 2 squared times 5 is 4 times 5. So the numbers the factors that are making up 20, we have 4 and 5. And we discover that 4 is a composite number, a composite of 2 times 2, but 5 is a prime number. So this 20 is a number that is made up of a composite number and a prime number. So we need to use these signs in this question. We have less than, equal to, or greater than. So using the signs, we indicate what the relationship is between these statements. The first statement we have is 2 to the power of 6, and on the other side, what I have is 2 to the power of 9. So we have 2 to the power of 6 and 2 to the power of 9. This 2 to the power of 6 means 2 has been repeated 6 times. 2 to the power of 9 means that 2 has been repeated 9 times. So we find out between 2 to the power of 6 and 2 to the power of 9, what is the relationship? So 2 to the power of 6 means my 2 has been repeated 6 times. So 2 times 2 is 4. 4 times 2 will give me 8. 8 times 2 is 16. 16 times 2, 32. 32 times 2, we get 64. So 2 to the power of 6 is 64. Then 2 to the power of 9, my 2 has been repeated 9 times. So 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32, 32 times 2, 64, 64 times 2, 128, 128 times 2, we have 256, 256 times 2, we have 512. So on this side we have 512. On my left hand side I have 64. So between 64 and 512, we discover that 64 is less than 512. So this sign means that this is less than. So 64 is less than 512. Another sum we have to compare. We need to give a comparison between 6 to the power of 4 and 5 to the power of 3. So I need to know what sign is between 6 to the power of 4 and 5 to the power of 3. 6 to the power of 4 means I multiply my 6 4 times. So I have 6 times 6 times 6. Then 5 to the power of 3 means I multiply 5 3 times. So 5 times 5 times 5. That gives us 125. 6 times 6 is 36. Times 36. 36 times 36, we are having, this is 36, right? 6 carry 3. 18 will give us 21. This is 18, carry 1. 9, that is 10. So we get 6, 9, 2, 1. So we are having 1296. On my right hand side, I have 125. So we get 1296 and 125. This number is bigger than this. So it means that the equation that is the sign that is between them is that 1296 is greater than 125. So this sign simply means that this is greater than. So we are having the two sides, 2 to the power of 4 and 4 squared. We need to find out what sign is in between them. So 2 to the power of 4 means 2 times 2 times 2 times 2, which gives us 4 times 4, which is 16. Then 4 to the power of 2 means that 4 is repeated twice, so 4 times 4, which gives us 16. So on the left hand side I have 16, on the right hand side I have 16, which means that the two sides are equal. So the sign that should be between them is equal to. So we look at factorials. When you're talking about factorials, if I'm having n factorial, then it simply means that we are multiplying the numbers starting from the digit you have, moving downwards. So if I'm having n factorial, it means that I have n multiplied by n minus 1 times n minus 2 all the way until I reach the number 1. So if, for instance, I have 9 factorial, then it means that what I'm multiplying is the numbers all the way from 9 backwards to 1. So I'll have 9 multiplied by 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that is the knowledge about the factorials that we need to know. So if you are given a number written in this form such that you have a number, then the sign after the number, it simply means that that is the factorial of that given number. We simply multiply the number backwards. So if I have 7 factorial, then it means I'm starting from 7 all the way back to 1. So I'll have 7 times 6 times 5 times 4 times 3 times 2 times 1. So 12 factorial, what does it mean? I'm having 12 times 11 times 10 times 9 times 8 times 7 times 5 times 4 times 3 times 2 times 1. So that is a knowledge on factorials that we need to know. That when we have a number, instead of writing all these numbers down, like for instance, you could be having maybe 1000 factorial. You can imagine writing down all these numbers, writing all the way from 1000 until you reach 1, instead of writing all those tedious work. So you simply get to write the number and put the sign after the number. So if you find that your number is, the numbers you have, the digits you have, or the factors you have are reducing in that order, if they are reducing in that order, you simply start with the highest digit and put this sign so that it shows that it is multiplication of numbers that are reducing downwards all the way to 1. So if somebody writes 5 factorial, then it simply means I'm having the multiplication of the numbers all the way from 5 to 1. So I'll have 5 times 4 times 3 times 2 times 1 as my 5 factorial. So this is what the knowledge of factorial means to us. So we've been looking at the prime numbers. And with the prime numbers, we've simply said that a prime number is a number that has only two factors, 1 and itself. So when you get a number that has only two factors, that is 1 and itself, then that number is referred to as a prime number. Another type of number we've looked at is a composite number. And we said that a composite number is a number that is made up of more than two prime numbers. I mean more than two factors. So when you get that your number has more than two factors, then that number is a composite number. Out of the composite numbers can be written in index form. What do we mean by index? Index form, we simply mean that we are having a repeated number that is occurring. When you are having a repeated multiplication, then you simply write the number as the base and find out how many times that number has been repeated, so that the number of times the number has been repeated will be our power. Then we are talking about the factorials. And with the factorials, we are simply saying that there are times when we need to write a number. And when you discover that the multiplication of that number is reducing backwards all the way to 1, then we say that that is a factorial that we are having. So when you have 9 factorial, for instance, it simply means I'm multiplying the number, reducing it backwards to 1. So we'll start all the way from 9, 8, 7, 6, 5, 4, 3, 2, and 1 as you multiply. So when you are multiplying that number in a reducing manner, then we are referring to it as a factorial. So you are having 9 factorial, 7 factorial, 10 factorial, and so on. So that is the detail we need to know about the factorials. Then when you are simplifying or when you are evaluating numbers that are involving indices or the index form, it means that simplify whatever index form you've been given before you go ahead and carry out the operation that has been given. Find out if you've been given two numbers that are in index form and you're supposed to subtract, find the solution, evaluate, expand the index, simplify that index, and get the calculation as it is. So this is all we need to know about the factors, prime factors, indices, and the factorials. Thank you.